I'm going to go over isotopes with you. I mentioned this in Dalton's atomic theory that we have discovered that there are isotopes. So they're going to be atoms of the same element with a different number of neutrons. Now remember, neutrons are neutral. They have no charge. So it doesn't change the properties. It just changes the size. So, isotopes can be written a couple of different ways. Probably the most common isotope that you ever hear about is carbon-14. Okay, so carbon-14 is what's used in radioactive carbon dating. It's just an isotope of carbon. If we look on the periodic table, carbon has an atomic number of 6. Okay, that means that it has 6 protons and 6 electrons, because any element on the periodic table is neutral, does not have a charge. So that means it has 6 protons and 6 electrons. If it's an ion, the number of electrons can change. Ions are an atom with a charge. So to find the number of neutrons, you're going to take the mass number and subtract away the atomic number. Okay, so I've already told you a little while ago, the mass number is where most of the mass of the atom is. So that, remember, is your number of protons and neutrons. That's the nucleus. And your atomic number you just find from the periodic table. So if we look at our periodic table, carbon is right here, and it has an atomic number of 6. Let's see if I can zoom in on it a little bit for you. Okay, so it has an atomic number of 6. Okay, so the mass number for this, mass number has to be given to you, like this right here, or you have to add up the number of protons and neutrons. So in this, we have 14 minus 6. Okay, so 14 minus 6 will give us the number of neutrons. Alright, so that means that we have 8 neutrons in carbon-14. It's still carbon, it still has all the properties of carbon, it just has a different number of neutrons than regular carbon. Regular carbon has 6 protons, 6 electrons, and if it's going along with all of these, it should have 6 neutrons. When you start getting isotopes, start getting a change in those. Okay, so if it's not written like this, it will be written out like this. So it's carbon, it gives you the mass number, and it goes ahead and gives you the atomic number. These are a lot easier if it's written out like this, because you just take 6 from 14 and it gives you the number of neutrons. Okay, so if we look at, if we're trying to find the number of protons, neutrons, and electrons, and let's do another really common isotope, uranium-238. Okay, so this is the mass number. So now we need to find the atomic number. Okay, so we're going to look on the periodic table. And we are going to find uranium. So let's see if I can get this to zoom in on it maybe. Uranium is down here at the bottom. It's kind of hard to see on this one. Okay. But it does have an atomic number of 92. That's what this number right here is. So atomic number is 92. So if you're looking for atomic number, we know that it's 92. So to find the number of neutrons, 238 minus 92. Now 92 is also going to be, the atomic number will also be the number of protons that it has. It will also have 92 electrons. Remember, protons are positive, electrons are negative. So in any atom from the periodic table, you should have the same number for protons and electrons. So we're going to take 238 minus 92, and that gives us 146 neutrons in that isotope. All right, so to recap, to find protons and electrons, that's just going to be your atomic number. To find number of neutrons, you're going to take mass number. Remember, most of the mass is in the nucleus, so that's your protons and neutrons, and subtract away the atomic number. Okay, and mass number has to be given to you, or they have to give you the number of protons and the number of neutrons so you can add them up. To get the mass number. Okay. Alright, and then isotopes can be written two ways. They can be written with the mass number out to the side, or they can be written with the mass number and the atomic number. So that's how you find the number of protons, neutrons, and electrons.